Welcome to Unit 6, Level 1 video notes. We're going to use the relationship between the probability of an event and the probability of its complement. We will also be creating tree diagrams, learning about probability. The probability of an event is the number of successful outcomes, which is how often an event occurs, out of the total number of outcomes, also called a sample space. And these are equally likely outcomes. Examples of probability would be like 3 out of 4. If you divide that, you get the decimal value, 0.75 tenths hundredths, which is really 75 hundredths. And 75 out of 100 is 75%. So all of these have the same value. The probability of an event is a number between 0 and 1 as a fraction or decimal, or if it's percentage, then 0% and 100%. Impossible probability, where an event will not occur, is 0 or 0%. And certain probability, the fact that you will definitely have an event occur, would be 1 or 100%. For our first example, a number is chosen at random from 1 to 10. We need to find the probability of the event occurring of not selecting a multiple of 3. Please read closely, write down those key words. We're not looking for a multiple of 3, we're looking for not a multiple of 3. Factors of 3 are 1 and 3, because 1 times 3 equals 3. Multiples of 3 are 3 times 1, or 3 times 2, or 3 times 3, 3 times 4, 3 times 5. These are multiples of 3, and so in our list of 1 through 10, we have 1, 2, 3 numbers that are multiples of 3. Well, I want everything not being a multiple of 3. So instead of 3 out of 10 successes, these are not multiples of 3. And that is 1, 2, 3, 4, 5, 6, 7 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible numbers. 7 tenths is our probability. This would be the same as 0.7 because that's 7 tenths. And that is really 70%. So 70% chance of not selecting a multiple of 3 from the numbers 1 through 10, which is our sample space. A very important vocabulary word is complement, and the complement of an event is all outcomes that are not the event. So the probability of an event occurring, this C means I'm talking about the complement of it, which is actually the probability of it not occurring. So I want the unsuccessful outcomes of the event out of the total equally likely outcomes. And if this is a decimal, it's 1, subtract that decimal. Or if you have it as a percent, it's 100% minus the percent. I'm going to try to make sense of the complement using these two examples. So the probability of a prime number 1 through 10 we first need to figure out what are the prime numbers. So prime numbers are divisible by 1 in itself, and 1 is neither considered prime or composite. So 1 is not a prime number. 2, the only factors are 1 times 2, so 2 is prime, 3 is prime, 1 times 3. 4 is not prime, it's composite because 2 times 2 is 4, as well as 1 and 4. 5 is 1 times 5, 6 is composite, 7 is prime, 8 is composite, 9 can be 3 times 3 as well as 1 times 9. So 9 is composite and 10 is composite. So the probability of choosing a prime number out of 10 is 4 successes out of 10, which does reduce to 2/5, but Mobius will take that 4 tenths, which is also 40%. This example looks exactly the same except this C, and that's the complement of finding the probability of choosing a prime number 1 through 10. And that's all the unsuccessful outcomes of this event. So finding a prime number, we already circled it. So this means not finding a prime number, not the event. So now we have 1 and 4, 6, 8, 9, and 10. Those are not considered prime, and that is 6 successes out of the 10. Now, another way we could have found that 6 out of 10 is doing the 1 subtract the probability of the event occurring. This is the probability of the event occurring. So 1 subtract 4/10. Well, how much more to make that whole? It is 6 out of 10. If you need the common denominator idea to see it, then change the 1 to 10 out of 10 and subtract the numerator. 10 subtract 4 is 6, and keep your denominator of 10. There's your 6/10. Our last example for the complements. The weather predicts a 40% chance of rain. What's the probability that it will not rain? The probability of it raining is 40%. Well, I want the complement, the probability that it will not rain. And that's what that C means. Since we're given the percent, we can use this part of finding the complement of an event, where we can do the complement is 100, subtract the chances of it raining here, and our answer is 60%. And our success of the event and unsuccess of the event equals that total of certain probability happening 100%. We might have a little bit of gaps in our background knowledge, so I developed this page to help us all have an even playing field. So one dice, that should say die. One die has 6 sides on it typically, so our sample space would be 1, 2, 3, 4, 5, and 6, because there are 6 total outcomes that could happen. Flipping a coin, there are 2 outcomes. You can either get a head or a tail. So how many possibilities could happen if I flipped a coin 3 times? On my first roll, I could flip. I could get a head or a tails. On my second flip, if I got a head the first time, I could get a head or a tail the second time. If I flipped a tail on the first time, I could also get a head or a tail the second time. So my second flip would be a head and a head, or a head and a tail and a head, or tail and a tail. I'm going to flip the coin one more time, so I could get a head, and then another head, or a head, tails, or I could get a head, tail, head, or a head, tail, tail. And if I start with the tail, a head, I could get another head, tail, 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 head, or tail, tail, tail. So that is on my third flip, 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So this is an example of flipping a coin 3 times, and there's 8 outcomes using this tree diagram. Well, we had 2 choices for the first flip, 2 choices for the second flip, 2 choices for the third flip, and 2 times 2 times 2 is 8. That's more of level 2, but level 1 is definitely being able to draw that tree diagram. Now for a deck of cards. We have to know that there's 52 total cards in a deck. If you've ever played 52 card pickup, yep, you're picking up 52 cards. All right, there are 4 suits: hearts, diamonds, clubs, and spades. Now, in each suit, there's a 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's also a jack, queen, and king. Now, the ace can be considered a 1 or 11. It depends what card game you're playing. I'm going to make it a 1 here. If you count them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards. So you have 13 hearts, ace through king, 13 diamonds, 13 clubs, and 13 spades. And also the jack, queen, and king are considered base cards. So now let's do the probability of choosing a heart out of this deck. Well, we know that there's 52 cards and there are 13 hearts. Another way you could have thought of it is there's 4 suits and one of those suits is a heart, so 1/4. Both of these fractions have the same value of 0.25. Mobius will accept either answer. The probability of choosing a black card. Clubs and spades are black, hearts and diamonds are reds. So 13 plus 13 is 26 out of 52. Or we can see that this is 2 suits of black, 2 suits of red, that's 2 out of 4, or 1/2. A half of the deck is black and a half of the deck is red. This example is in level 2. It's just a nice spot to put it in level 1 today. So the sample for rolling 2 dice and finding their sum is given to the right. So there are 6 times 6 total outcomes for rolling 2 dice. If I roll a 1 and a 1, the sum is 2. And if you roll a 1 and a 1, you just rolled snake eyes. If you rolled a 6 and a 6, that's called boxcars. And that has a sum of 12. I can get 7 by rolling a 6 and a 1, or a 2 and a 5, or a 4 and a 3, or if the other dice was a 4 and a 3, the other was a 5 and a 2, or a 6 and 1. So lots of different outcomes here, a total of 36. So let's do letter C. Find the probability the sum is greater than 9. Well, greater than 9. If I have greater than $9 in my pocket, that means I don't have 9, I have more than 9. So I need all the sums more than 9. And so I have 3, 4, 5, 6. That is 6 successes out of 36, which does reduce to 1/6. Mobius will accept either. And this brings up my last point here. At most 5 or at least 5. What do these two things mean? Hit pause after I ask this question. Would you rather have at most $5 in your pocket or at least $5 in your pocket? If you said at least 5, you are correct, because that would mean you have $5 or more. So that's greater than or equal to 5. This time it includes it versus greater than 5 or greater than 9, it didn't include it. If I have at most 5, that means I can't have more than that. So it's less than or equal to 5. At most 5 means I can't go over it. So less than or equal to 5. Hopefully that helps answer some things. These include 5. Greater than, less than, that would not include the number. Good luck on your level 1 homework.